In this video, we're going to build the Merton options pricing calculator. We have the equations for which we need to solve. The purpose of this exercise is to teach you to enter complex equations into Excel and to get the correct answer. I'm going to teach you some of the things that I do, and I'll give you an opportunity to practice. So we're going to go ahead and calculate several of the elements required to calculate and price call and put options using the Merton method. Let's begin by calculating D sub 1. As you can see, I have the formula for D sub 1 here. We're going to begin by identifying the elements that we want to calculate. I have a few elements here that I want to group together. I have the elements to the left of this plus sign. I'm going to group those together. The elements to the right of this plus sign, including multiplication times time. So that's another group. Then I want to group both of these because they're the numerator and put them over this denominator, which I'll also group. All the grouping done with parentheses in Excel. So go ahead and start the numerator, and that's the logarithm of s over x plus, and I'll group the values to the right of the plus sign, r minus k plus stock volatility, sigma, raised to the second power, or squared, that quantity over 2. We have that group. Then we're going to multiply that times t, or time. And we have the calculations to the right of the plus sign, and there is the numerator. We'll divide that by, in this quantity, stock volatility, sigma, times the square root of time. Square root, and then the denominator, press enter, and I get 0.630. That is D sub 1. Now I have to calculate D sub 1 before I can calculate D sub 2, because D sub 1 is an element in the D sub 2 calculation. So let's calculate D sub 2. It equals D sub 1 minus stock volatility times square root of time. That's 0.3821. We'll calculate the natural logarithm of e. It's not a formula for that per se, it's just a function in Excel. And that function is exp to the first power. And that gives you 2.72 if you display it to 2 places, but Excel is calculating it out many places and uses that full number in the calculation. So if you just type 2.72 into your equation, you'll get the wrong answer because the number that Excel is using is much more robust, and you want to use that entire number. So create that value there and leave it there, and we'll point to it in future equations. Now we'll go ahead and calculate the value of the call option. We'll build that equation. So C equals, and I'm going to go ahead now and calculate things to the left of the minus sign in the equation, and then I'll calculate things to the right of the minus sign. So the quantity to the left of the minus sign is S times E, and E is raised to the minus K times T, and we multiply that times N, which is the normal standard distribution. We're going to use that function in Excel. Now, there's a difference. So later on, we'll calculate the derivative of the normal standard distribution for D sub 1, and that will be indicated with N prime. You need to pay attention when you see N or N prime. In this case, we see N, so we're going to use the norm.s.dist. That's what N indicates, and it's N of D sub 1. We want that to be cumulative. We always do in the normal standard distribution, so we set that second part of the syntax to true. All right, that takes care of the value to the left of the minus sign. Now here's the minus sign, and we're going to get the value to the right of the minus sign, so that's X times E, and E is raised to the negative R times T, and we take that quantity and we multiply it times, again, N, the normal standard distribution of D sub 2. So norm.s.dist of D sub 2. We need to set that to true, indicate cumulative. And now we have the values to the right of the minus sign. There is our equation. We'll press enter. We get 16.17. That is the current value of the call option. We'll go ahead and get the current value of the put option. Very similar looking equation to C. So let's go ahead and build that. We're going to build the elements to the left of the plus sign in the equation first, then the elements to the right of the plus sign. So to the left of the plus sign, we have a minus S, stock price, times E, and E is raised to the negative K times T. That quantity is then multiplied times N, or the standard normal distribution, for a minus D sub 1. So we want norm.s.dist of a minus D sub 1. And we want that to be cumulative, so we indicate true as the second part of the syntax. Now we have the values to the left of the plus sign, so we close that. The plus sign, now the values to the right, we'll calculate those. That is X times E, and E is raised to the minus R, risk-free interest rate, times T. That quantity is then multiplied times the normal standard distribution for a minus D sub 2. We want that to be cumulative, so we'll indicate true as the second part of that syntax. And we close off the normal standard distribution, and then we close off the values to the right of the plus sign. We press enter and we get the put price of $4.50. Now, for use in future exercises, we're going to calculate the derivative of the normal standard distribution for D sub 1 and for D sub 2. Notice the notation n prime looks similar to the normal standard distribution, which is n, but they're different. If you're solving equations, be sure you enter the correct element depending on the notation. So if it calls for the normal standard distribution, do that. If it calls for the derivative of the normal standard distribution, come and get this value. All right. Let's go ahead and calculate that. So we'll start with an equal sign, get the quantities to the left of the multiplication. So I'll do that quantity 1 over the square root of the quantity 2 times pi, which is pi in Excel with a left and a right parenthesis with nothing in the middle. Then I'll close off my square root function. Then I'll close off the quantity to the left of multiplication. Now I'll do multiplication, and I'll start that quantity, and that begins with an E. So up and point to E, and that is raised to the quantity negative. Watch this second parenthesis here. This is important. Negative D sub 1 squared raised to the second power. That quantity then over 2. That gives us the exponent then. So I close the exponent off now with the parenthesis. And I close off that quantity to the right of multiplication. I press enter. I get 0.3271. That is correct. Now I'll go ahead and calculate the derivative of the normal standard distribution for D sub 2. Very similar looking equation as the one above. Good practice. I'll take that quantity to the left of multiplication, which is 1 over the square root of the quantity 2 times pi, which is pi left parenthesis, right parenthesis. And that quantity for the square root, and now close off. That's the quantity now before multiplication, then multiplication, now the quantity after multiplication. I'm going to take E, and E is raised the inverse of the quantity D sub 2 squared. All right, so now we have the inverse of that quantity. Then we're going to take that over 2. Then we'll go ahead and close off the exponent. We have our exponent in place now. And then we will close off the value to the right of multiplication. We get 0.3709, which is the derivative of the normal standard distribution for D sub 2. So we have completed then the Merton option pricing calculator with the derivative for the normal standard distribution for D sub 1 and the derivative of the normal standard distribution for D sub 2.